Work done. Whenever you push a heavy crate across a rough floor, you do work. The further the crate is pushed, or the rougher the floor, the more work is done. The work done by a force is defined as force in newtons multiplied by the distance moved in the direction of the applied force, and that is measured in meters. Let's consider 4 different scenarios. In the first scenario, the crate is being pushed, and as you can see, the direction of the force is the same as the direction of motion. So in this case, work is being done. In our second scenario, the bag is being held across the female's shoulder. The direction of the force and the direction of motion are perpendicular, so no work is being done. In our third case, a contact force is being used to lift the bag of groceries upwards. The direction of force and the direction of motion are exactly the same, so there is work being done vertically. In our fourth example, the direction of the contact force holding up the grocery is vertical and the direction of motion is horizontal. So in this case, no work is being done. The unit of work is the joule, and that is defined as the work done when a force of 1 Newton moves its point of application by 1 meter along the line of action of the force. Now let's consider an example of a man pushing a crate up an inclined plane. If the applied force is 200 newtons at an angle of 30 degrees to the horizontal, let us work out or calculate the work done if the box moves 5 meters along the horizontal. In this example, it is important to pay close attention to the direction of the force and the direction of motion. It is important that when we're calculating work done, that we multiply, we're finding the product of the force and the force moved in the direction of motion, or the component of the force in the same direction as the motion. Remember, work done is equals to force times distance moved in the direction of the applied force. So in this case, we have an inclined plane 30 degrees above the horizontal. We expect our box to move a total distance of 5 meters, and the applied force is 200 newtons. We must first work out the component of our force that is in the same direction as the motion that we're concerned with. So in the same direction as the horizontal motion, 5 meters. So we're looking for the horizontal component of our force. From trigonometry, we know that that will be defined as 200 cos 30. So the force applied in the direction of motion is 200 cos 30 newtons. Therefore, the work done will be equals to 5 times 200 times cos 30. Your scientific calculator will do this for you, but first make sure that your calculator is in the right mode. If it is not, then change it to a degree mode. Once you've done that, you can simply compute 5 times 200 cos 30 degrees. You get an answer of 866.025438. It is convention to round your answer if not specified to 3 significant figures. So our answer in this case will be 866 joules to 3 significant figures.